Assalamu alaikum. Fifth and last lecture of Fundamental of Soil Science course. This lecture will focus on soil fertility and microbiology. Soil as a medium for plant growth. Plant nutrition is defined as the process of the plant absorption of essential element necessary for its growth in a valid form. Scientists discover around 100 chemical elements. Nonetheless, only 17 of them are essential for plant growth. To be classified as essential, the element need to meet the following criteria. First, the plant cannot complete the element to be essential for plant growth should meet the following criteria. Number one, the plant cannot complete its life cycle, seeds to new seeds. Without this element, the plant can complete its life cycle. Then it should be essential. The second is the element's function cannot be replaced by another element. You can use an element instead of another one. The element is directly involved in the plant growth and reproduction. So the 17 essential element is the carbon, hydrogen, oxygen, nitrogen, phosphorus, potassium, calcium, magnesium, sulfur, boron, chloride, copper, iron, manganese, molybdenum, nickel, and zinc. These 17 elements are considered essential element. The first 7 element is considered macronutrient, and the remaining is a micronutrient. So the top from carbon to sulfur, first 9 element is considered macronutrient. The remaining is the micronutrient. The first 3 elements, carbon, hydrogen, and oxygen, the plant can absorb them from air or water. Carbon from air, hydrogen from water, and oxygen from air and water. Nitrogen from air and soil. Air and soil. The remaining element, the plant absorb them from soils. So we can classify the element into non-mineral nutrient and mineral nutrient. Non-mineral nutrient is carbon, hydrogen, oxygen. The classification is based on because they are derived from air and water rather than from the soil. Although these 3 elements represent approximately 95% of plant biomass, carbon and hydrogen, oxygen represent around 95% of plant biomass. They are generally given little attention in plant nutrition because they are always in sufficient supply. Carbon is and hydrogen and oxygen are plenty in water and air, so the plant do not suffer from their deficiency. Mineral neutral. The remaining 14 mineral nutrients are classified either macronutrient, as I told you, or micronutrient based on their plant requirement. There are 6 macronutrients: nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. The macronutrient in addition to carbon, hydrogen, and oxygen. So the macronutrient is 9, as I told you. 6 macronutrient remaining plant absorbed them from the soil: nitrogen, phosphorus, potassium, calcium, and until sulfur. The macronutrient, the 3 macronutrient NPK, nitrogen, phosphorus, and potassium are often classified as primary macronutrient because deficiency of them are more common than secondary macronutrient calcium, magnesium, and sulfur. Usually, a plant suffer from nitrogen and phosphorus deficiency, especially in new reclaimed soil. The micronutrient, as I told you, boron, chloride, copper, until zinc. Usually, plant do not suffer from chloride deficiency because it is found in high concentration around the universe. So you can find chloride everywhere, so the plant do not suffer from its deficiency. Most of macronutrients represent 0.1 to 5% of the plant. 5% mean 100 multiplied in 10,000 to convert from percentage to part per million. I explained this before. To 5,000 part per million of dry tissue. Remember, the 3 CHO represent 95% of the plant. The macronutrient represent from 0.1 to 5%, and the micronutrient represent around 0.025%. Okay. This is the form of the plant can absorb the nutrient. It means that the nutrient should be on this form to the plant be able to absorb them. Some forms maybe the plant be found on the soil. Nonetheless, maybe the element found on the soil. Nonetheless, the plant can't absorb it due to its form is unavailable or insoluble on the soil solution. Like if you found calcium phosphate, for example, the calcium phosphate is precipitate and do not dissolve, and the plant can't absorb. So although you may find a nutrient in the soil, however, this nutrient may be unavailable for a plant if do not found on this form. Step for obtaining nutrient from the solid phase. The first is solubilization of the element from the solid phase into the soil solution. Then movement of the element from any point in the soil solution into outer root wall. Then transfer of the element from outer to inner plant root. Translocation inside the plant from root to shoot. The movement of element from any point in soil solution into outer root wall can be achieved by different methods. What is the method for movement of the nutrient? The method is diffusion, root interception, mass flow, and etc. So you can now summarize here the meaning of soil fertility. When you say, you can say that this soil is fertile or not. The soil fertility is the ability of soil to supply plant with all essential nutrients. If the soil contains all essential nutrients, you can call this soil as a fertile. But this element should be in a valid form and in sufficient quantity. Let me define the soil fertility again. The soil fertility is the ability of the soil to supply plant with all essential nutrients in a valid form and sufficient quantity. The factor affecting soil fertility is pH, soil texture, CEC, organic matter content, salinity, calcium carbonate content. A negative impact is found with the presence of calcium carbonate content. The calcium carbonate decrease the availability of nutrient. The salinity also cause problem. Organic matter increase the fertility. Organic matter CEC increase fertility. Soil texture, clay soil is more fertile than sandy soil. The acid pH is favorable for the element to be available to the plant. Let me go through another topic. We finish now a general brief of soil fertility and nutrient, macronutrient, macro and micronutrient, which called essential elements. Now I go through to a new topic called soil pollution. Soil is a sink or receptor of many chemical residues, and when these substances enter the soil, they become part of it and affect all forms of life. May destroy the ecosystem, the balance of the soil. The microorganism may negatively affect the microorganism's activity on the soil. It is necessary to know the nature of these wastes and their interaction in the soil, and how to manage and dispose. Why soil pollution is important? Because the soil is a source of our food. The soil provides elements to plant. If the soil is contaminated, the plant will absorb this contaminant and accumulate on its body, then will immediately transfer to the human. So soil health and pollution has a direct impact to the human health. Soil pollution are pesticide, inorganic pollutant like heavy metal, and organic wastes. Organic pollutant like pesticides. The fate of pesticides in the soil may be volatilized, absorbed, break down, absorbed or adsorbed, leaching or degraded. The inorganic pollutants such as heavy metals like cadmium, nickel, lead, chromium, and so on. Organic wastes like